In this session, we'll be looking at the normal distribution with focus on what is the normal distribution, typical example of normally distributed data, and what is the standardized normal distribution. Just a quick recap on what we have mentioned in our earlier sessions. You have learned about different types of data, one of which is the quantitative data, which is a type of data that can be measured, counted, or quantified in some ways. There are two types: the continuous data. A continuous data is a data that can assume any value on a continuum. Examples include height of student, lifetime of component, time required to complete a task, thickness of an items, and so on. The second one is the discrete data. This is the type of data that can take whole number values, such as the number of cars sold, number of children in a household, and so on. In this session, we will deal with a probability distribution that represent a continuous numerical variable, such as height of student. Generally, continuous probability distribution vary by shape of the area under a curve, as shown in the figures here. Some of the distribution, such as the normal distribution and the uniform distribution, have symmetrical shape, while others, such as an exponential distribution, do not. The most commonly used continuous distribution is the normal distribution. That's the one we will focus on in this module. It plays an important role in statistics as many continuous variables used in decision making have distribution that closely resemble the normal distribution, which allows this distribution to be used to estimate values for those variables. Some of the characteristics of a normal distribution include being bell-shaped, namely denser at the center and less dense at the tails. It has a single peak. It's symmetric around the mean. The mean, median, and mode are equal. The area under the normal curve is equals to 1. Normal distributions are defined by two parameters, the mean and the standard deviation. Changing the mu, which is the mean, shifts the distribution either to the left or to the right, while changing sigma, which is the standard deviation, increases or decreases the spread of the distribution. In practice, many variables have distribution that closely resemble the important theoretical properties of the normal distribution. For example, the following histogram summarizes the height of 600,000 adults using a class width of 20 centimeter. Reducing the class width to 10 centimeter gives the following histogram. Reducing even further to a class interval using a class interval of 5 centimeter gives a histogram that looks like this. Can be reduced further to 2.5 centimeter, and when we reduce to the interval to 1.25 centimeter, the frequency histogram and polygon gives distribution that is approximately satisfying the normal distribution. This is true for many other variables in real life, such as weight of adults or children, shoe sizes, IQ, the time it takes for a component, e.g., light bulb, to fail, and many other variables. Any normal distribution can be transformed into the standardized normal distribution, usually referred to as the Z distribution. The reason for this transformation is to allow one to look up values in a normal probability table and avoid tedious and complex computation of normal equation that would otherwise have been required. The Z distribution has a mean of 0 and a standard deviation of 1. To compute normal probability, you will need to transform X unit into Z unit. In order to convert a normally distributed variable X to a standardized normal variable Z, you will subtract the mean of X and divide by its standard deviation as given by this equation here. The mean of Z distribution is always 0, while its standard deviation is 1. The values above the mean always have positive Z values, while those below the mean are negative. To finish up with this session, suppose one is asked, what do the following Z-score mean? A Z-score of minus 2.3 and that of 1.8. For minus 2.3, it means it is 2.3 standard deviations below the mean, while that of 1.8 means it is 1.8 standard deviation above the mean. To summarize this session, we have looked at what normal distribution is, what are the typical examples of normally distributed data, and finally, what the standard normal distribution is.